So in this video, I want to talk to you about being able to identify when an equation is a straight line graph. So not by looking at the graph, by looking at the equation. Can you tell if I write an equation down that that will give you a straight line graph? So, first of all, straight line graphs are referred to as linear graphs or linear functions. I'm referring to linear graphs here because, rather than functions, because in the previous video we looked at vertical lines, x equals 3, for example, but that's not a function. So I'm being quite careful with my wording here. Now, we refer to it as linear, and it's coming from, you can see the word line inside of it. Okay? So, linear graphs, and I should say now linear functions, can be written in the form of y equals mx plus c. Now, we're going to look later about what the m represents and what the c represents. That's not what this video is about. It's about, can I get the equation back into this format? If so, then I know that it is a straight line graph. So let's start with an example. Let's look at y equals 8x plus 2. Okay? This is in that same structural format. The m is 8 and the c is 2. Okay? Now what I'm going to do is I'm going to rearrange this equation. I know that that is a straight line graph. Okay? So you're going to have to run with me on that. And we're going to see why throughout this section. So given that that is a straight line graph, let's start rearranging things. Well, the first thing you might do is go, well, I could write the 2 and the 8x round the other way, couldn't I? I could write it like that, 2 plus 8x. Haven't changed anything. 8x plus 2 is the same as 2 plus 8x. So these two represent precisely the same graph. It's just written in a slightly different way. I could also, I could subtract 8x from both sides. Now if I subtract 8x from the right hand side, I've got to do the same with the left hand side. So I would subtract 8x from the left hand side, and I'd be left with 2 on the right hand side. So all I've done is rearrange the equation, and that's perfectly fine. That represents exactly the same graph. So I could rearrange those two terms. Just like I swapped the 8x and the 2, I could swap those two. I could write that as minus 8x plus y equals 2. And this is still a straight line graph. I could instead have subtracted the 2 from both sides. So y minus 2 equals 8x. Straight line graph. Same graph as the other ones. I could rearrange those two terms. Minus 2 plus y equals 8x. In fact, I could have subtracted the 8x and the 2 from both sides, all in one go. If I subtract 8x and 2 from that side, then I'll be left with 0 on the right hand side. I could have subtracted y from both sides and ended up with this. So the reason why I'm doing this, the reason why I'm manipulating this, is because I want you to appreciate that not just that all of these represent the same line, the same graph, but the fact that visually these all look different, but that they all represent straight line graphs. And the reason why they all represent straight line graphs is because in all of these cases, you have one x, one y. You don't have x squareds or x cubes or y squareds or y cubes or square roots of x or square roots of y or 1 over x or 1 over y. You've just got an x and a y. They are being multiplied by a number, so 8 in that case, minus 1 in that case. You're not multiplying the x and the y together, they're separate things. You've got an 8x and a takeaway y, you've got an 8x and a 1y, you've got a minus 8x and a y and an 8x there. So they are separate things. They can be on the same side of the equation of the equal sign, they can be on opposite sides, whatever. As long as you've got something x and something y, and they're not on the same side, they're not multiplied together or anything. They could be on two sides or they could be on the same side. Okay? These are straight line equations. The x here is a linear term. We refer to it as a linear term because it's not x squared, it's not x cubed, it's just one single x, x to the 1. Y is linear as well because it's just y to the 1. You could have y equals x. That's a straight line graph. Okay? You could have y take away 2x is 0. Same thing, you've got one single x, one single y. Okay? So, all of these are straight line graphs. And it's your job to be able to look at the equation and go, yep, that's a straight line graph. And I don't need to do anything to it. I don't need to manipulate it. I should be able to spot that from the outset.